Welcome. It's about time. It's 11:55. I know I'm right before lunch, so I'll promise to speak fast enough for you to pick up something from my talk, of course, but at the same time to share my knowledge as much as I can with you about the controllers. My name is Maciej. I work for Red Hat, and I'm part of the both Kubernetes core team and OpenShift core team. If you have any questions about either of the projects, I'm very happy to answer them all, or at least the one that I know the answer for. So today we'll be talking about controllers. So, okay. Better. Controllers. How many of you, if you hear the word controller, thinks about this? Nobody? Like, seriously? People. Okay, so you are, at least there's a handful of you, that are a very happy person and fun person. Unfortunately, I'm a little bit off the hook, because for me, controller is this. It's, this is actually a CronJob controller. I managed to fit in this 400 lines of code, but to be honest, it's almost for 400 lines of code. If you count the additional utilities, etc., it will be more close to 1,000 lines of code. And but the good thing, it's probably the smallest controller that we have in Kubernetes world. So, but still, for a newcomer, it might be quite overwhelming to look through it and figure out what's going on. There's a lot of use cases that we are covering in every single controller. So during this presentation, I'm hoping to give you the core components of every single controller. I'm hoping that after the presentation, you will feel comfortable reading the code of a controller or even writing your own controller. Let me raise your hand, whoever wrote a controller or seen a source code of a controller. This doesn't count. Okay, there's some of you. That's nice. So, okay, these 400 lines of code, let me try to squash it up so that it's more comprehensible for you. That's what the controller actually looks like. This is the core piece of a controller. So after we created the controller structure, we initiated with some stuff that I'll be talking about in a few moments. We do goroutine that is basically doing just this. It's processing every single item from the queue, picking it up, do whatever you want to do with your controller, push it back to the queue or ignore it, update the status, and continue. This is basically the entire logic of every single controller within the Kubernetes world. And when I'm talking about controllers, this applies to CRDs as well as the core controllers. All of them are working in the same way. But then again, if you're a newcomer, it's pretty overwhelming. Where do you start? How to write your own controller? Or where to look for stuff like the one that I just mentioned? So you can start just like me. When I was writing my first controller, the Job controller, back in the old days, when Kubernetes was small and not that many folks knew about it, I actually opened replication controller. And reading the replication controller, I was replicating the same logic within the Job controller. It worked pretty well. But my advantage was at the time that I was already a Kubernetes contributor for some time, and I knew more or less how to go through the entire Kubernetes stack. Besides, there was nothing else at the time that I could actually pick it up. So thankfully for you, the stuff is so much easier these days. You have two possibilities and numerous blog posts, tutorials, or the simplest thing, just reach out to myself personally on Slack. There was a Twitter handle, GitHub handle, like everything on the first slide, and I'm going to repeat it on my last slide. I'll be more than happy to help you with anything. And additionally, like I said, there's so many already written controllers, starting from simple all the way to the super advanced controllers. So This is actually part of the main Kubernetes repo. It's being synced with the main repo, and we ensure that this is always working, this sample controller. The sample controller is very simple. It is supposed to help you get started. Unfortunately, writing controllers these days still requires writing some amount of boilerplate. And that's unfortunately something that we are hard working on to get rid of. But you need to know the boilerplate more or less to feel comfortable with the rest. There's other project that sets up the boilerplate for you. If you use KubeBuilder is very helpful if you're starting with building your own CRDs. It will generate the types that go for you. It will generate the framework for your controller, and you can actually focus only on filling in the logic. But then again, it is nice to know the base details for what fits with which block and how the blocks should interact with each other. Does that make sense so far? Okay, so ahead of us there's nifty-gritty details. We're going to be looking at some code. I promise it won't be that hard, and but I'm not going to be throwing at you tons and tons of code as well, because like I said, there's the sample controller and the KubeBuilder that are very helpful to get started. So let me re-show you back the main control loop. And within that loop, there are 3 elements that I can already point to that we will be focusing on. The first one is actually, we're looking at the process next item, is the queue. The second one will be the sync handler, and there has to be something that is filling in the queue. So let's start with the queue. The queue is a pretty simple topic. Are you familiar with queues? Generally, that's a first in, first out queue. There's no magic behind it. You can set it up pretty easily. There are several rate limiters available within the queue project, the default one, and the other ones are exponential failure rate limiter. There's a fast slow rate limiter, and there you can also combine the limiters using max of rate limiters. Although personally, I'm always using the exponential fail rate limiter. So that's pretty obvious. There's no magic behind it. You put stuff into the queue, you take it out in the sync loop, and the work keeps going on over and over again. So the most important piece of every single controller is this, the shared informers. Remember the CronJob controller that I showed you at the beginning? Of all the controllers that I showed you, please do not take the CronJob controller as an example. I wrote it, but it has a major flaw. That major flaw is that it is not using the shared informers. And the reason for that, there's a very important reason. The CronJob controller was written before the shared informers were introduced. I need to find the time to rewrite the CronJob controller to use the shared informers. And the CronJob controller is slightly different than all the other controllers. So it takes a little bit more time for me to actually pick it up and improve it. If you have the time, if you're willing to do it, I'll be more than happy to help you with this as well. So let me know, and we can get some code cranking going on. So the shared informer, what it is, that's the funny thing. I was looking through the entire Kubernetes repo. Every Kubernetes developer, if you ask him, yeah, I know what a shared informer is. Everyone should be using it, and everyone are using it. But to be honest, there's no documentation about what a shared informer is. It's this type of tribal knowledge that everyone has, that everyone possesses, but nobody is actually competent enough to write a doc about it or even explain you in human words what it does. So I'm gonna try. So that's the definition that I put together. So shared informer is a shared data cache, and it is distributing the data to all the listeners that are interested in knowing about the changes that are happening to those data. Towards the end, I have a pretty nifty picture that is summarizing the interactions in the controller, and that is actually focusing a lot on the shared informers a lot. So I'm hoping that that bit will help you to get the idea much better. So the most important part of the shared informers is the event handlers. This is how you register your interest in specific object updates, whether that will be a addition of an object, creation of an object, an update to the object, or removal of the object. There are 3 functions that you need to register your interest in. And basically, if you look at every single controller that it is available out there, all they do is they will look what was sent in the event listener, and they will put the information about that object into the queue. Sometimes the update handler is a little bit more complicated in that it will verify if it's actually needed for the controller to process the data during the sync loop. Does that make sense so far? This is the crucial bit, basically, of every single controller. The other important element of that cache that we just talked about it, which is the shared informer, is the listers. There was a pretty good question about 2 days ago during the contributor summit. Why the listers interface is different from the client Go, and why would you use a listers versus regular client Go? So the reasons for using listers is they are designed specifically to be used within controllers. They have the access to the cache. Using client Go, you always hit the API server. And obviously, if you're working with, 10,000 deployments or even more, you do care about using the cache as much as possible rather than going back to the API server. This is the problem within the CronJob controller. CronJob controller currently lists, which is very expensive operation, lists all the cron jobs within the cluster and lists all the jobs within the cluster to be able to identify which jobs match to which controller and what to do with them. This is super expensive operation. I know that there are companies that are using cron jobs up to a couple thousand, and it is working fine. But with my knowledge of the controller and what I just told you, it will be harder if they exceed the number a little bit higher. So the shared informers is the key for working with controllers. So you add the informers, and then you register the event handlers, and then you save for yourself the listers. And now we go to the main loop. This is where you actually implement the logic of your controller. Let's go one line by one. So the queue that I've mentioned you at the beginning is not storing the actual objects. It is storing something that we called a meta namespace key, which is basically a namespace and the name of the resource bundled together. There are even specific helper methods that are designed to encode and decode those keys back and forth to namespace name and in the other directions. So that will be the first invocation of every sync handler in your code to get the namespace of the resource that you want to work with and the specific name of the resource. After you're done with that, you will actually get the object from the cache. Depending on your controller, you might be getting more than just one object. In my particular case, I'm just getting a pod, because if I would try to put more resources here, then obviously that won't fit into the screen, and I was very I was very inclined to fit in as much of the code, but not too much, into the slide. Does that make sense so far? Okay. And here goes the most important thing of all, right after the shared informers. Because you're using a shared cache, all the resources you're getting are you're not getting a an object. You're getting a pointer to the cache object, which means if you're just reading the object, you're fine, you don't have to do anything. If you want to modify the object, you need to invoke deep copy on the object. That was purposely done for the controllers, but every single controller writer has to remember that. We had tons of problems when we switched to this pattern currently. There were some weird controllers stuff happening if you don't do that. So always ensure to do a deep copy. But be careful. Deep copy is very expensive operation as well. So only do deep copy if you will be modifying the object. The current deployment controller has a nice to-do next to the deep copy. We're doing deep copy too soon. Because it's like fourth operation in the sync handler if you go through the deployment controller. So you should be 100% sure that, yes, I'm going to be updating the object and that I should do the deep copy. That's pretty much it. You should be now focusing on your logic, your entire logic of your deployment, your job, controller, replica set, whatever, the controller you're working on is actually where you put that. The job controller will be looking through the spec, ensuring that there's this many pods running at the time. Fine, I'm done. I'm going to update the status. Yes, it's fine if I need to. The deployment controller will ensure that, yes, there's a replica set created, that it matches the spec that the user provided. The daemon set controller will ensure that, yes, there's a pod running on every single node, etc., etc., etc. This is how simple it actually is. I know that I've heard lots of people saying that, well, writing controllers is very hard. But for me personally, controllers are probably the simplest things in the entire cube. There are harder stuff like the API machinery, and that is a pain for me personally. Okay, remember the picture that I mentioned you? This is basically how the shared informers are interacting with the controllers. And all the credit goes to this guy here. I didn't do it. And it pretty nicely depicts how the Kubernetes API, how the shared informers are listening to changes coming from the Kubernetes API, and how they are then pushing those changes to all the listeners, and then the controllers are responsible for the event handlers to place the information about, yes, this object of mine was updated. I'm going to put it in the queue, and then I'm going to take it from the queue, do whatever I want to do within my controller, update the resource status, and on and on and on. Does that make sense? Okay, so as a closing remarks, let me share you with some ground rules for every single controller within the Kubernetes ecosystem. There's a link also in the contributors repo so that you can read a little bit more. But here are the 11 rules. Always operate on a single item at a time. By single, I mean if you're working with replication controllers, it will be one replication controller. But obviously, a replication controller operates on that replication controller, but also on all the pods that it is managing. So one resource at a time doesn't mean literally just one resource, because it won't be possible and feasible to do it. A job will be always a job, and that many pods that every single job instance is managing at a time. So that's very important. Number two, you need to ensure that you are not hard-coding any ordering between the items that you are processing in the queue. It should be entirely random. There should not be any interconnection between the objects that you are working on. Remember, this is highly reliable, super scaled, big system at the end of the day that we were talking about. Use shared informers. This is highlighted and I've talked about it. I've given you example of poorly written controller, or rather not updated yet, but I'm working on it, I promise you. There's one thing that I haven't mentioned. At the beginning of your controllers, when you are setting up everything, you need to wait for the caches to be ready. So there's a nicely function that you just need to wait for to notify your controller that yes, the caches are ready, they synced. It might take some time at the beginning of the controller. If you forget about it, it might happen that the initial actions of your controller will not be reflecting the actual state of the cluster, which is obviously as bad as well. In the long run, it will be fine, but the startup will be very bad. So ensure that you wait for that. I said it before, but I'm going to repeat it. There are other actors in the system. So you're not the only controller. Be mindful when you're writing stuff to the API. You need to be prepared that, for example, when you're updating your resource, there might be a conflict because somebody else in the meantime updated your resource. Your controller has to be prepared for the conflicts. You need to resync your object once again or repeat your update process. Ensure that you are providing to users a reasonable error messages for your controllers. There are events, and the events is the best options for you as a controller author to provide information. If there's any error happening with your resource that you cannot update it properly, enqueue the same object once again so that it will be resynced in a while again. And maybe the error is just a temporary issue that will be gone within a couple minutes. We need to ensure that Kubernetes always keeps running at no matter what. It has to provide constant functionality to the users. The last two that I'm going to be talking about are very specific to your use case. First one is something that we call observed generation. This is basically if your resource provides something that is called a generation, which means you are encoding within the object specification and information that yes, there's something new happening to the object, and the controller should pick it up. You should provide that information in the observed generation field in the metadata of an object. For example, currently job controller, I know I'm going to be talking about both job and CronJob controller, and the reason is that I know all about the bugs that they have because I wrote both of them. The job controller has this problem. I'm honest with all of that. The job controller has this following problem. It currently requires all the pods created by the job controller to exist all the time. It's fine if your job is creating 10, 100, maybe 1,000 pods. But it will be a problem if your job will start creating 10,000, 100,000, or 1,000,000 pods. The reason for that is the current calculation that we have for the status of the job is based on the pods that finished or are currently running or are to be run. We should be calculating the status based on a generation. We should be encoding the information that yes, these pods were already processed and updated in the status. And for that, we should be using generation information. It's slightly more complicated. If you want to know more about it, please reach out to me. I'll be more than happy to help to answer you. Maybe a little bit simpler example is deployment. So whenever you're updating deployment, if there is a modification to the specification of a deployment, we're going to update the generation number to a higher number, and the controller just reads that instead of comparing the entire spec. And the last one is something that I did not talk about it before, and I specifically want to cover at the end, is owner references. Owner references is a topic that we put together about 3 releases ago. This is about embedding the information about your parents in the objects that you are creating. For example, a job controller would put a owner reference information within all the pods that it is creating. Why it is important? This is important when you are removing the objects. If I'm removing my job, the majority of time, I want all the pods that are connected, that are created by the job, to be gone as well. The current garbage collection mechanism that we have within the Kubernetes is looking at the owner references. You can explicitly say, I don't care about the kids, just leave them, I want to have just my job removed. But the default behavior is remove job and all the pods. And actually the garbage collection will figure it out, all the pods first, remove the pods first, and only the job at the end. Obviously for the job controller and pods, that's very simple, there's only one level. But for a deployment creates replica sets, which creates pods. If you would be manually removing that, and we were doing that in a kubectl command delete, in kubectl delete command, then that was a pain because we had to remove all the pods, and we had to remove all the replica sets, and only after that we were able to remove the actual deployment. With the garbage collection, all the deployment controller has to do is set the owner references appropriately at the replication controller. The replica set controller will set the owner references at the pod level. Then when I'm removing the deployment, all the way down is happening automatically because the garbage collection is looking at the owner references. That is actually a pretty straightforward idea. The owner references is something like a namespace and name and the type of the resource that owns the object. That's basically it. And that's basically all I had for you. If you have any questions, I'll be more than happy to answer all of them. Sure. Yeah, sure. The question was how it relates to the operator framework. Well, the operator framework it's very similar to the controller, you might say. It is more to help you operate other stuff, and operator will be more targeted at a specific application, like in the case that we have etcd operator. The etcd operator knows how to interact with etcd specifically. It has the knowledge of the hierarchy and everything, how the etcd should work. So it is somehow a controller, but it is specific to running a particular application. A controller is for running a particular resource within the Kubernetes ecosystem, whether that will be a deployment, whether that will be your particular CRD. So that's basically all.
How would you feel about writing controllers in, for instance, Python?
Yeah, that is a very good question. So the question was about writing controllers in different languages. Actually, here was Python, and you have a beer from me just for asking about Python. So unfortunately, the shared informers are not available in any other language than Go, and that is the biggest problem. Client Go, I mean, there are clients for Kubernetes API in other languages, and Python was actually the second one right after Go. There are Java and something else, but I can't remember, that are being generated from the API. The only downside currently is that you would have to implement your own shared informers type of a functionality, or you are dealing basically with the problems of interacting with the with the Kubernetes API directly instead of through the cache, which is obviously the benefit of having and not having a cache is a significant problem. But then again, it's fun, and I think somebody wrote actually a controller with Python for. Yeah, that's awesome. So I would like to see that happening. I remember that during the Kubernetes Summit, we discussed about the Sheraton Format, maybe in other languages, but we'll see how things will go.
So one of the recommended patterns when you're writing controllers, specifically for writing custom operators, is each controller sits in its own pod. Say you have different CRDs and you write controllers for each one of them. Now, from at least the diagram or what I could understand about reading up on Sheraton Formers, it is within that client Go process. So if I'm running different pods, each of them running client Go for each CRD or resource, does that work, or is that a good idea or not?
I'm not sure if I correctly understood. You're asking about running controllers in a pod, your CRD controller in a pod, or that's something?
You have multiple controllers
Uh-huh.
for a different kind of CRD doing a specific.
Yes. Okay. So currently in the core Kubernetes, all the controllers, each controller is a separate mechanism. Each is running in their own Go routine, as is. So if we're talking about the CRDs, every CRD will have their own controller because controller is always tied to a specific type of a resource. So yes, in that case, every CRD, every different CRD, but not instances like, you know what I mean? Every instance of your CRD is not, but the type overall has just one controller for your. But different CRDs will have different controllers. Does that answer your question, more or less?
No, I'll get that.
Yeah, we can talk. Sure.
Curious about testing controllers. So, is there any best practice, or what do you recommend?
So there are different levels how you can control how you should test your controller. There's no specific patterns or recommendation. Obviously, the sync handler method will be the most important and the most heavily tested element in all the controllers if you go through the current core Kubernetes controllers. The sync handler, where you feed the sync handler with some data in and expect that at the end of the execution, the state will be this and not the other way around. So, for example, for both Job and CronJob, we have a lot of tests, and we're like literally good couple hundred of table tests for just the specific use cases. And whenever I'm adding some new use cases because somebody created a bug or I'm always trying to add those use cases into those tables. The tables are pretty nifty themselves, but it takes a while to get used to it because we created lots of one-letter variables so that you can fit in one line the entire specification for a test. So it takes a while. Even for me, sometimes when I'm returning to that, oh yeah, okay, this is that. But it's at the end of the day, it works pretty well. And then that covers the main functionality. And then you need to have a E2E test that will be actually stress testing your particular controller, whether it is interacting the way you expect it to be. And that includes creating, deleting, scaling up, down, removing pods from the controller if you're managing pods, or breaking and ensuring that the controller will pick it up the way you design it to be. There's no patterns by itself, but it's these two areas that you will be focusing on for your tests. Sure.
So, if there are two controllers working on the same object, how are the informers kept coherent? As in, if one controller changes the object, then how does the second controller come to know, or the informer in the second controller come to know about the change? Is there a way to send notification?
There is nothing like that to send notifications between the controllers. None of the current controllers is running Or actually, we are. If we are running the same controllers, you always have the leader that is actually working on it, and the backup one, as you know, so that it picks it up. There's only one controller of any kind running once at a time. At least that's the implementation that we have in OpenShift.
If there are multiple for high availability, there are multiple instances of the same controller.
We always try to keep some kind of a leader election for the controllers. There's only one running at a time. Like all of them are running, but only one is actually picking up the work. That's what we implemented in OpenShift. And if you look at the Kubernetes, I think they have something like that similarly.
Two different controllers.
Two different controllers is a separate thing, and like I said, you cannot escape from the fact that there are other actors in the system. You just need to be prepared to reevaluate the same object once again upon conflict or upon any other problem. There was somebody else that had a question before. I'm not sure if he left or okay. Go ahead.
Yeah, related to it, so it is usually going to this conformance test suite or somewhere else in the code base?
That depends on the author. But we're trying hard to have the core controllers being part of the conformance suite.
Okay, but there is some place where some other is this, right? So it's like closer to original code. I'm just figuring out how many test suites we have.
Oh, there are several. It also depends because some tests are specifically for performance testing. They will be in a separate suite. But generally, they all live in a one place. It'll be only labeled differently. Whether, the tags, whether you want to have these run as a conformance. For the conformance, we're trying to focus only on the car functionality of every single controller to be actually run within the conformance, because then that also applies to all the Kubernetes distributions. If you want to be a certified Kubernetes distribution, you need to pass all the conformance testing. Okay. Thank you very much. Have a good lunch.